Hello students, welcome back. We were just discussing Bohr models of atoms and looking at the distribution of electrons in the shells outside of the nucleus. So just to return to that idea, we have down here in the bottom left-hand corner of the slide, oxygen with its two numbers. Our atomic symbol is O for oxygen, and the lower value number is 8. That is our atomic number. And remember, that refers to the number of protons in the nucleus of an atom. 16, the greater value number, is the mass number, and that refers to the number of protons plus the number of neutrons in the nucleus. So if we do a little subtraction here, 16 minus 8, it gives us the number of neutrons. So these are fairly easy elements. Oxygen would have 8 neutrons and 8 electrons, or 8 protons in the nucleus. To give 8 plus 8 is 16 as the mass number. Now, I was saying at the end of the last video that in a neutral atom, the number of protons equals the number of electrons. The positive charged protons and the negatively charged electrons cancel each other out to give an overall neutral atom. And so in these pictures, you can see 8 electrons, those little blue dots outside here on the shells, 8 blue dots to balance out the 8 protons in the nucleus. Now over here we have a little trickier one. This is phosphorus. Atomic symbol is P. Atomic number is 15, so 15 neutrons. And then if we had 15 protons, if we had 15 neutrons, we would have 30 as our mass number, but we have 31, so that means we have 16 neutrons in the nucleus. No matter what there, we have 15 electrons balancing out the protons. And sulfur, S, has 16 protons and 16 neutrons to give us a mass number of 32, 16 electrons. So when we look at atoms individually, they don't seem to be that important, especially for fermentation science. We're talking about sauerkraut eventually. But when we put the atoms together, we make molecules and compounds. So a molecule is 2 or more atoms bonded together. We have some molecules that are called elemental molecules, like O2, H2, and N2. So the little subscript following the atomic symbol refers to the number of atoms in this compound, or in this molecule. So O2 has 2 atoms of oxygen bonded together. H2 has 2 atoms of hydrogen, and N2 has 2 atoms of nitrogen. So these are in their elemental form, and they're not that much different than the single atom of the element. When we combine different elements, though, we get interesting compounds that do have differences from their parent elements. CO2 is a common molecule that we will see throughout this course. There is, in this, 1 atom of carbon and 2 atoms of oxygen bonded together to make this CO2, which is carbon dioxide. Water is another compound molecule with 2 atoms of hydrogen and 1 atom of oxygen. I want to point out, when you do not see a subscript number following an atomic symbol, it is 1. Chemistry just does not put the ones, just lets that atomic symbol be the individual. Okay. And then we have a very large compound molecule here, C6H12O6. I say large, that's just relative to what we've seen before. This has 6 carbons, 12 hydrogens, and 6 oxygens bonded together to make glucose, a simple sugar. And it's one of the sugars that fermenting organisms can break down to make fermented byproducts. To get those atoms to come together, we need to bond them. Bonds between atoms are caused by electrons in the outer shells. And the process of a bond formation is called a reaction. So we're going to talk about a few different types of bonds here. This one is the bonding of sodium and chlorine. This is called an ionic bond, where we make 2 different ions. So here's sodium, Na, and chlorine, Cl, sodium will lose its outermost electron and it will be taken up by chlorine. Now, when sodium does that, it loses a negative charge, so it becomes a positively charged ion, we call it. So you'll see it written as Na+. Okay? It has more protons now than it has electrons. We lost that balance. In chlorine, we'll see written as Cl-, and this is now a negative chloride ion with an extra negative particle. Now, because we have a positive and a negative, they attract each other, just like magnets, and we end up with the compound molecule of sodium chloride, NaCl. This is what it looks like in crystalline form. Over on the left is a picture of a large sodium chloride crystal, and on the right is what it would look like if we were able to see the atoms making it up. Another type of bond is called a covalent bond, and that involves sharing of electrons. Now, covalent bonds are most often found in biological molecules, especially carbon-based molecules. Carbon has 4 outer electrons. When we look at the Bohr model, if you want to refer back to that slide, you can. Those 4 outer electrons will tend to be shared with other atoms to make covalent molecules. And some simple ones are shown in this slide. Here is a simple covalent molecule with carbon and 4 hydrogens. So those 4 outer electrons are shared with 4 hydrogen atoms to make methane, CH4. Methane is a gas at room temperature and has a very unique smell to it. It's found in natural gas and can be a gas released by organisms. Hydrogen gas, this is an elemental molecule of 2 hydrogen atoms, is a covalent molecule. It's sharing those electrons, and so same with oxygen. Now, not all sharing is equal. Anyone can tell us that. Atoms that have an equal sharing or an equal affinity for electrons will share those electrons equally. And so the bonded electrons, I abbreviate with E negative, will spend about equal time with both atoms. Now, this makes the overall molecule nonpolar. That means it doesn't have a charge to it. Some common nonpolar items are things like oils. Polar covalent bonds occur when we have atoms that have unequal affinity for the electrons. So one atom really wants the electrons, the other atom not so much. So when bonded covalently, the bonded electron will spend more time with one atom than the other. So that atom that gets the electron more becomes slightly negative. The other atom becomes slightly positive because it doesn't have that negative charge around it. So now we have a slight charge on this molecule and we call it polar. It's got polarity. One polar molecule that we will see is water, but water itself is polar. So H2O, the oxygen and the 2 hydrogens are polar. But when we put multiple water molecules together, we see that there is an interaction between them. So the hydrogens are slightly positively charged, the oxygens are slightly negative, and those will be attracted to other water molecules. Okay, so the slightly positive hydrogen of one molecule will be attracted to the slightly negative oxygen of another, forming a weak bond called the hydrogen bond. This is easily broken, but many together can be very strong, and this is what holds water together as a liquid at room temperature. These bonds between water molecules will break when we evaporate water and release smaller clusters of water molecules or individual water molecules as gaseous water. This is up close and personal, looking at the molecular configuration of one water molecule. And this is what many of them look like together. So we have the Greek symbol sigma here, meaning slight, refers to slight in chemistry. Hydrogen has a slight positive charge here and here, and the oxygen has that slight negative charge. So the oxygen of this molecule is bonded to the hydrogen of this molecule. So that's that weak hydrogen bond between molecules, shown as a dotted line here. And this forms a lattice with several different water molecules. So that is it for our basic chemistry. We will be looking at how these simple molecules interact and are applied to fermentation as we go forward. Please send me emails if you have any questions.